Flexible Screens by Lior Bezalel, Oren Sheffer, and Tznir Cohen. What are we going to talk about today? Screens in our lives, lacks of the existing screens, the development of flexible screens, the problems that prevent the mass production of this technology, what there is to do in order to deal with these problems. A screen allows us to observe images, videos, and other information at any time and at any place like home, job, or even in the bosom of nature. In the beginning, screens were uncommon and were in use only in military and high class. The most common kind of monitors today are LCD, but there are many downfalls to its usage, such as intricate and expensive manufacturing. There are many monitors that are being made but destroyed in the process of manufacturing, thus are not ready for usage and make the manufacturing and marketing expenses higher. The LCD monitors are relatively heavy and difficult for operating. To watch the monitors, they need to be hung on a very massive wall, unlike a picture frame that needs only a nail. These monitors require a lot of electricity, they use a very complicated technology, and watching a direct light on them is not optimal. These disadvantages brought a demand to a new kind of monitors in the market. These kind of monitors need a new kind of technology. The development of the screen has got a long way until now. Two-color screen, green color screen, multicolor screen, flat screens, touch screen, curved screen. And what is the next generation?
Science developed electronic ink. The ink's version employs thin capsules filled with a clear fluid containing positively charged white particles, negatively charged black ones. The capsules are arranged as pixels, and electric charge applies to each pixel pull either the black or the white particles toward the top of the capsule. Unlike an LCD, this image does not require backlighting. Instead, the user relies on reflected light, as he would if he were reading a sheet of printed paper. Moreover, once the particles in the capsules have settled down, they stay put. That means the image remains on the screen without drawing power. Further dose of electricity is required only when the image changes. The next stage was to manufacture the screens on plastic metal. Plastic Logic, the firm that makes an electrophoretic reader that is built the LCD way, but on plastic rather than on glass. The firm uses an adapted version of LCD manufacturing which employs electronic ink and plastic substrates to make its screens. Plastic Logic's prototype reader, which has a screens about the size of a magazine, is a mere 7 mm thick and weighs less than 450 grams. It should run for a week in normal use before its battery needs recharging.
Simplify the manufacturing process. The breakthrough here was to work out a way to simplify the process, by which the electronic circuit that controls the pixel is carved out of layers of conducting, semiconducting, and insulating materials. This involves the repeated application of resistive materials to protect those parts of the layers being etched that need to be preserved. HP scientists, however, have worked out how to print a layer of resistive materials of variable heights on the top of all other layers. After each stage of the etching process, a fixed depth of this dissolves away, exposing a different part of the circuit to etching chemicals. The result is a continuous process, much like a printing press. This promises to become a cost-effective mass production method which HP will license to other producers, said the company research director. Once that happens, he hopes, flexible screen could be used in all sorts of devices. the problems that prevent the mass production of this technology. Right now, it can be created only in black and white monitors, without the usage of colors with this new technology. Uquista, a sub-firm of Philips, a big Dutch electronic company, is trying something called electroweighting. This uses an electrical field to modify the surface tension of colored oil and water within pixels that are mounted on a flexible Teflon base. As each pixel is activated, the weighting process of the oil and water change and making color visible. Another approach is to use material that emit light. Some firms, such as Sony, are looking at organic light that emitting diodes components from a thin film of organic molecules, which generate light in response to an electrical current. This approach is reckoned to have a potential for use in ultra-thin wall-hang television sets. Finally, we showed that the screens are important in everyday use of our lives. We talked about the reason that lead to the invention of the flexible screens, the problems that scientists encounter with the development of the flexible screen, and finally how to deal with those problems.